So what I'd like to do now is introduce this new low drift thermocouple option, or thermocouple cable, that is the focus of this presentation. We've already talked about why Type K and Type M base metal thermocouples are the most widely used temperature sensor in industry, particularly in the temperature region above 800 degrees C or 1470 Fahrenheit. We've already mentioned that the MIMS construction is the best regarding its practical design because it shows less drift than other forms. However, it also can show significantly high levels of drift above 1000 degrees C, above 1800 Fahrenheit temperature range. These are the exact reasons why researchers at the University of Cambridge, working under Dr. Michele Schiavini, have spent the last 10 years researching and developing a new low drift base metal thermocouple option. What I'd like to do now is give you a little bit of a history behind the development, and as I've already mentioned, it's been worked on now some 10 years by researchers at the University of Cambridge. They started the project looking at temperature measurement using contact sensors, i.e. thermocouples. The work focused on studying the drift characteristics of these base metal thermocouples and studying the reasons why these thermocouples actually drift in use. There was actually some very innovative testing developed by the researchers at Cambridge, to such an extent they were able to determine and categorize the drift component of the individual conductors or individual thermocouple legs of a thermocouple combination under various thermal conditions. Directly from this research, this new form of low drift MIMS, mineral insulated metal sheath thermocouple cable, has been developed directly from the research conducted in the Cambridge laboratories. So I'd like to give you an overall summary of that development. Initially, the work, as already mentioned, started looking at all thermocouple types, particularly Type K. Researchers worked on both bare wire and MIMS constructions. However, this presentation really going to focus on the drift developments and work found on the MIMS designs. What the researchers found at Cambridge on the MIMS constructions was that the main cause of drift was due to contamination coming from the outer sheathing of the construction itself. This is quite an irony, really. The design of the thermocouple with the powder and the outer metal sheathing was actually fulfilling its job of protecting the thermocouple wires from the environments and contamination from the environments in which they were located. However, now it was the actual metal sheathing became the main source of contamination and therefore the main source of drift. It would be difficult to change the outer sheathings because these have been designed and were fulfilling their role of design in industrial applications. But the researchers at Cambridge put forward the concept of introducing a barrier that would sit between the outer metal sheathing, and the actual thermocouple conductors themselves. And this would stop the contamination or reduce the contamination, and in turn stop or reduce the drift.